Hello, everyone. Welcome to another episode of Deep Dive Knowledge Talk. Can you explain the concept of domain-specific large language models and why they are needed in various industries?
Of course. Imagine you have a super smart language model that can understand and generate human-like text. This is a general-purpose language model, BioGPT 3.2. It has been trained on a wide range of data from the internet, making it very good at many tasks. However, when it comes to specific industries like healthcare, finance, or law, these general LLMs may not have the specialized knowledge and understanding needed to be truly helpful. That's where domain-specific LLMs come in. Domain-specific LLMs are models that have been trained or fine-tuned to excel at tasks specific to a certain industry or domain. They have a deep understanding of the context, terminology, and requirements of that industry. This makes them more accurate and reliable in providing insights, generating content, or assisting in decision-making for businesses in those industries. For example, in healthcare, a domain-specific LLM can understand medical terminology, analyze patient records, and provide recommendations for treatment options. In finance, it can evaluate investment opportunities, analyze market trends, and assist in financial planning. In law, it can review legal documents, provide guidance on legal matters, and help in contract analysis. So, domain-specific LLMs are needed in various industries because they provide a specialized level of understanding and knowledge that can greatly enhance productivity, accuracy, and efficiency in specific tasks within those industries.
That's a great explanation. It really highlights the importance of domain-specific LLMs in different industries. Now, in the study, you mentioned the limitations of general-purpose LLMs. Could you elaborate on what these limitations are and how domain-specific LLMs overcome them?
According to the study, general-purpose LLMs have limitations in dealing with long context. For example, GPT-4 can only handle 4K tokens, although a version with 32 co-tokens is in the pipeline. This means that general LLMs may struggle to understand and generate relevant output for lengthy texts or conversations. Domain-specific LLMs address these limitations by being trained with specialized knowledge within a specific domain. These custom models have a better language understanding of the domain and can operate more accurately within their specific context. By fine-tuning a foundational model or building a domain-specific model from scratch, these LLMs can be tailored for specific tasks or industries, enabling them to produce more relevant and comprehensible output. In a nutshell, while general-purpose LLMs have limitations in handling long contexts, domain-specific LLMs overcome this by being trained with specialized knowledge, making them more effective and precise within their specific domain.
That's fascinating. It's impressive how domain-specific LLMs can overcome the limitations of general-purpose LLMs by being trained with specialized knowledge. In the study, you mentioned that there are different techniques for creating domain-specific LLMs, including building a model from scratch and fine-tuning existing models. Could you explain these techniques in more detail and discuss their advantages or disadvantages?
There are several techniques for creating domain-specific LLMs, each with its own advantages and disadvantages. Let's discuss 3 common techniques. 1. Build an entire domain-specific model from scratch. This technique involves training a language model specifically for a particular domain using a large dataset. Advantages. It allows for complete customization and control over the model's behavior in the desired domain. The model can be fine-tuned to understand and generate domain-specific language accurately. Disadvantages. It requires a significant amount of high-quality domain-specific training data, computational resources, and time. It may not be feasible for organizations with limited resources, or if the domain is niche and lacks sufficient data. 2. Fine-tune an LM for domain-specific needs. This approach involves taking a pre-trained general LLM, such as GPT-3, and further training it on a smaller domain-specific dataset. Advantages. It requires lesser resources and time compared to training from scratch. The pre-trained model already has a good understanding of general language, which can be further fine-tuned for domain-specific tasks. Disadvantages. Fine-tuning may not achieve the same level of customization as training from scratch. The original model's biases and limitations may carry over to the fine-tuned model. Additionally, fine-tuning requires a representative domain-specific dataset for effective results. 3. Retrieval-augmented generation. This technique combines the strengths of retrieval models and generation model. It involves retrieving relevant information from a knowledge base and using it to augment the generated output. Advantages. It allows the LM to leverage external sources of information, ensuring accurate and contextually relevant responses. It can enhance the model's performance in a domain by incorporating domain-specific knowledge. Disadvantages. Retrieving information from a knowledge base can be time-consuming and may require additional computational resources. The accuracy of the generated output depends on the quality and relevance of the retrieved information. Each technique has its merits depending on the specific requirements and constraints of the domain. It's essential to consider factors like available resources, data availability, desired level of customization, and the trade-off between accuracy and efficiency when choosing a technique for creating a domain-specific LM.
Thank you for the detailed explanation of the different techniques for creating domain-specific LLMs. It's interesting to see the advantages and disadvantages of each approach. In the study, you mentioned the importance of data quality, scalability, and monitoring model performance during the training process. Could you elaborate on why these factors are crucial and how they contribute to the successful development of domain-specific LLMs?
Data quality, scalability, and monitoring model performance are crucial factors in the successful development of domain-specific LMS because they directly impact the accuracy, efficiency, and effectiveness of the trained model. Data quality is important because the performance of an LM heavily relies on the data it is trained on. High-quality data ensures that the model learns the desired patterns and relationships accurately. If the training data is noisy or contains biases, the LM may produce inaccurate or biased results. Therefore, ensuring data quality is essential to obtain reliable and trustworthy domain-specific LMS. 8. Scalability is another important factor because it determines the ability of the LM to handle large amounts of data and perform complex tasks efficiently. Organizations often have vast amounts of data, and the LM should be able to process and analyze this data effectively. Additionally, as the organization's needs evolve, the LM should be scalable enough to adapt to new requirements without significant retraining or rebuilding. Monitoring model performance is crucial to ensure that the LM continues to meet expectations and perform well in real-world scenarios. By constantly monitoring the model, ML teams can identify any performance issues, such as underfitting or bias, and take appropriate actions to address them. This may involve refining the model with additional data, training, or hyperparameter tuning. Regular monitoring helps to keep the LM relevant and effective, especially in dynamic and evolving environments. Overall, data quality, scalability, and monitoring model performance are essential for the successful development of domain-specific LMS as they contribute to the accuracy, efficiency, and adaptability of the models, ensuring they meet the specific needs of the organization or task at hand.
Thank you for explaining the importance of data quality, scalability, and monitoring model performance in the development of domain-specific LLMs. It's clear that these factors play a significant role in ensuring the accuracy and effectiveness of the trained models. In the study, you also mentioned the potential benefits of domain-specific LLMs in industries such as banking, retail, pharmaceuticals, and education. Could you provide some examples of how domain-specific LLMs have been utilized in these industries and the specific benefits they have provided?